Welcome to the first lesson in geometry. I want to begin speaking about a pretty popular topic in the history of geometry, and that is Euclid's elements. So what is Euclid's elements? Well, Elements is a book that Euclid wrote approximately 300 BC that really was, for the next 2,000 years, the cornerstone of mathematics. When people thought about mathematics for the next 2,000 years after this book was written, they thought about Euclid's Elements. So really, this was widely considered to be one of the most important texts, besides many religious texts. So to start, there are different ways that Euclid laid out a lot of the elements of geometry and what he saw around him. Well, he usually began with a process, and this process started with definitions. So definitions could be considered, an example could be of a point, just some point in two-dimensional space. Another one could be a line. A line is any continuous path between 2 points. So at that time, even this, which we might consider a curve now, is still followed the definition of a line. Moving on from definitions, he moved into postulates. So an example of a postulate could talk about a circle with a center of some point A, can be comprised of its radius and every single radius of this length all the way around 360 degrees around that center. So if you drew a radius that was the same length as the initial radius, and then you drew another one, and then another one, and then another one, and so on, if you kept doing that for infinity and then made a point at the end of the radius, all of these were points, then you would form a circle. You would form a circle with some radius r. All right, and then from postulates, he continued on into axioms. So axioms and postulates can really be grouped together as well, but an example of an axiom could be, he spoke about if you have some A which is equal to some B, and then you have this A is also equal to some C, then the B is equal to C. So that's a pretty popular axiom in most of mathematics. And then finally, after postulates and axioms, there are propositions. Or as we may see them, theorems. So let's see what I can do here. So an example of a proposition that he may have written is one in particular, which is a good way to go over one of these propositions, is, let me just change the size of my font here, it's a little bit big. So there's an example of proposition 35. So this is one of his propositions, and it says that if two right lines, and at that time a right line, you're probably thinking of a right angle 90 degrees. When he was writing Euclid's Elements, he meant by right line, he was saying a straight line, essentially, because like we were saying before in the definitions, a line wasn't always straight. It could have been a curve, as we call it today. If two right lines in a circle mutually cut each other, the rectangle contained under the segments, let me just move this down, contained under the segments of the one is equal to the rectangle under the segments of the other. All right. So let's read this again. So proposition 35 says that if two right lines or straight lines in a circle mutually cut each other, so they both intersect, the rectangle contained under the segments of the one is equal to the rectangle under the segments of the other. All right, so let's draw this out, because this could be interesting to look at. Sorry about that. All right. So let's draw a circle to the best of our ability here. And let's draw two right lines in the circle, or two straight lines in the circle. Okay, that's a little bit off, but it's okay. And then we'll label these segments A, B, C, D. And what this is saying is that the rectangle formed, because at the time of Euclid's Elements, instead of thinking A times B, as we may think now that you've completed some algebra, you see many times some constant times some other constant, or some variable times another variable. If you have two constants multiplied together in A times B, then that's not that difficult for you to think about. It's just some number times some other number. But at the time, they thought in terms of area. So this area could be considered as the rectangle . Oh, let me fix that line. The rectangle with A and length B. And then, so the area of this rectangle is what they were really thinking about when they were thinking of A times B. So, so this proposition could be written as AB is equal to CD. So one more interesting idea I wanted to talk about Euclid as well, is that when Euclid was thinking about things, when Euclid was trying to form shapes, he used the idea of forming shapes using really only two tools. And these two tools, were the straight edge and a compass. So if you've seen a compass before, not the directional compass, but the compass that forms the perfect circle, you put the needle in the middle and you kind of drag the pencil or drawing object around, and it creates a perfect circle around the center. And then a straight edge, as we would consider a ruler or something of the sort. So the way this was done is, so say we're given some line, and let's say we're given some horizontal line here in space, and asked, actually, we don't want it to be a we don't want it to be a continuous line. We just want a line segment. So let's just say we're given some line, and then we're asked to find the midpoint. Well, we draw the line with our straight edge, and then we'd take our compass, and we'd start drawing some semicircles. So if we were to draw a semicircle kind of like this is rough, and then another one like this. Oh, that should go through. And then we took our straight edge again and kind of drew a line through the intersection of these two semicircles. Well, where this line was dropped into and where it intersects our initial line is the midpoint. This is our midpoint. And then, based on this, we can also form the shape of an equilateral triangle. If we just draw up to our intersection points and to our endpoints, and then initially over here. So these are all equal. So this gives us an equilateral triangle. So that's actually used to make, this method can be used to make several shapes. There are some shapes that it cannot make. I believe one of those is a pentagon. I don't think that this can be used to make a pentagon, or a nonagon. I'm not sure about that, but I believe it cannot make a pentagon and a couple other shapes as well. But this is just kind of an interesting view into how shapes were formed thousands of years ago and into the future even. And then the last thing that I wanted to talk about is, and the reason why I kind of separated this geometry, is the real term of where geometry comes from. Well, geo comes from the term or the word earth, and then metry comes from our idea of measurement. So if we really think of geometry this way, it could give us a different idea of what we're doing when we're solving these problems, or we're proving whatever we're proving, or we're using postulates or axioms or theorems. So this is something to keep in mind.